This is example number 5 of section 13.4. So we have two blocks A and block B are placed on an inclined plane and are released. That means that they start from rest. The coefficient friction between the blocks and the surface are 0.5. So here we have a rough surface, 0.1, and in B, 0.3. And then we are asked to find the force developed in the link between the two blocks when we release those blocks. But let's see the solution then. Well, let's see how do we do that. We will use our equation of motion, right? And then we are asked to find a force, which is the force developed in the link. And we have to find then the acceleration to be able to find the force. To do that, I will do the free body diagrams. Since we are asked to find the force in the link, we have to cut, so to say, the link and do the free body diagrams of the both bodies separate so that that force appears. So let's do the free body diagram of block A. So we have an inclined surface, and then we have that link that we just cut, right? In order to apply our equation of motion, we actually, the first step should be always to put our coordinate system. Since we have an inclined plane and everything occurs, all the motion occurs parallel to that plane, I will put my coordinate system in this direction. So it's inclined. See, if this is 30 degrees, this is 30 degrees, right? And this is 30 degrees too. And I will put my forces according to the reactions produced by the boards. In this case, the support is the plane. So we have a normal force that is always perpendicular to the surface. Let's call this normal force NA. We have a weight. I'm going to write the weight in another color because that's not an unknown. And I like to write the unknowns in different colors from the variables that we know. How much is the weight of that block? Is the mass of the block, which is 10 kilograms by the gravity. And we know this is, even though we put our system inclined, the gravity is always vertical. Our weight always goes down. What other forces we get? We have friction, and the friction opposes to motion. If this whole system goes parallel to the inclined surface, then, and it goes down because the only acceleration that is acting upon the blocks is the gravity, no, we know that this is moving downward. So our friction goes up, let's call it friction, and it's a kinetic friction. We know that when we have already motion, the kinetic force is always equals to the coefficient of friction times the normal force. And besides that, we have also our force developed in the link. So I'm going to put the force, I can put it in either direction. I just decided to put my link as in that direction. I could have put it, but what I do know is that that link, since it doesn't have a weight, is a weightless link, and it only creates forces along its actual direction. So this is my free body diagram of block A. I'm also going to draw my free body diagram of block B. And it's very similar to block A. So by action and reaction, I have the same exact force, but in the opposite direction. I have another normal force. I'm going to call it NB. I have my friction force that opposes to the motion, and that force is also my kinetic coefficient, friction coefficient times the normal, and I have the weight. The weight in this case is not unknown either, and it's the mass times the gravity. So those are my two free body diagrams, and then I have to do my equations of motion. I will try to do it right here because I don't have that much space, but if I add my forces in x and in y directions from both diagrams, I can solve the forces. So if I want to, what I want to find actually is when I say force in the link is that F that so I call it F is what I want to find. So if you see that F, when adding forces in x direction, will be related to my friction force. So I'm going to add forces in y direction first to find my normal force, which will be a function of the weight, and then I will add forces in my x direction. So, equations of motion for block A. I have here forces in y. So in y I see that I don't have any motion. So I will have weight, which is 9.81 in a negative direction, right? In a negative direction times, and I have to decompose that force, and that angle is 30 degrees, right? So it will be cosine of 30 degrees plus NA equals 0. So NA is equals to 10 times 9.8 times cosine of 30, you know that is square root of 3 over 2, and that's equals to 84.96 newtons. So I already have NA. I will do the same for block B. For block B, forces in y direction is equal 0 too, because I don't have any motion in the y directions, and I have a negative 6.981 cosine of 30 plus NB is equal to 0. So NB is equals to 6.981 square root of 3 over 2, which is equals to 50.97. So I have my two normal forces. That means that I do have my friction forces too, because I already related the friction force to the normal force by the coefficient forces. So now I'm going to add forces for block A, forces in X. This is negative F, negative FAK, and then I have positive this little component of the weight, which is plus 9.81 sine of 30. And that will be equals to mass times acceleration. When I see this block, since this link is connecting both blocks, I have only one acceleration for the whole system in x will be that. So that's common acceleration for block A and for block B. So that will be my first equation. I can actually write it like F equals, I'm going to pass F to the side, equals to negative mu A, which is mu A 0.1 times the normal, which I got is 84.96 plus 10.981 sine of 30 0.5, right? And then I have minus mass A. This is a mass of block A. I'm adding forces for A, which is 10 A. So that's my first equation. And then for block B, I add forces in X, and I will say I will have positive F minus FBK plus the component of the weight in X direction, which will be 9.81 sine of 30. And that will be equals to mass B AX. So that will be my second equation. I will solve for F. Here I have F equals to mass B minus X, and I'm going to put it very similar to that one. So it will be the friction coefficient for B, 0.3, times the normal that I already found, 50.97. This is positive, this is negative, 6.9.81. Sine of 30 is 0.5, and that's to the other side, so what, plus 6AX. And that's my second equation. I have those two equations, and I can make those two F equals, find AX, and then plug that into one of them and find the F, what I'm looking for. The thing is that I have two equations with two unknowns, solving the system, so solving the system of equations. I get the results. F is equals to 6.37 newtons, and AX is equals to 3.42 meters over second square. So please solve the system of equations and get the results yourself, but what you have to do is just make those two equations equal, solve for AX, and then plug that AX into one of the equations and you find F. And that F is what we were looking for, which is the force in the link F, and the force developed in that link when we release both blocks, and so we release those blocks and an acceleration is created because they are subjected to gravity. Look at the acceleration that those blocks have is not the same as gravity, it's less because they are in an inclined surface and they have friction between them and the surface. And that's the force.